robin builds her nest from the mud and snow, with a breast red as morning and a song soft and clear. She sings to her young ones, I'm right here, I'm right here. Little wings of wonder, little hearts yet to fly. Mother birds are watching underneath the white sky. Every feather she gives you was laid down with love. You are held, little one, by the warmth from above.
Imagine a biological machine, right? And this thing, it weighs less than a single U.S. nickel.
Which is, almost nothing.
Literally less than a nickel. And its heart is firing at 1,200 beats per minute.
It's just staggering to even think about that number.
Yeah, it really is.
Yeah.
And then twice a year, driven by these environmental cues, it takes that tiny nickel-sized frame and executes a 500-mile continuous flight straight across the open water of the Gulf of Mexico.
Right, across the Gulf, which if you look closely at those metrics, your brain just sort of instinctively tries to categorize them as a physical impossibility.
Oh, totally.
The metabolic output required to sustain that kind of exertion, it pushes the absolute boundaries of what vertebrate biology can actually do.
It reads like an error in the evolutionary code. But, it's entirely real. Welcome to today's deep dive, everyone.
Glad to be here for this one.
We are pulling out the key insights from an incredible set of field notes and biological breakdowns today. Our mission is to unpack a really fascinating chapter of natural history. We're calling it The Ruby-Throated Hummingbird Small Bird Fierce Heart.
I love that title.
Right. And we're going to deconstruct exactly how this animal survives. Because what we're looking at is a masterclass in solo parenting, extreme physiology, and just survival against all odds.
Absolutely. And to properly analyze their reproductive strategy, you first have to grasp the baseline ecology we're dealing with here.
Yeah, set the stage for us.
Well, by almost any physiological measure, the ruby-throated hummingbird Archilochus colubris is existing on this metabolic razor's edge. The source material accurately describes their daily existence as a metabolic inferno.
A metabolic inferno. That's such a great phrase.
It really paints a picture, right? To simply avoid starvation, they have to consume roughly half their own body weight in nectar and insect biomass every single day.
Half their body weight. Okay, let's unpack this. Because to understand how the female raises her young, we have to look at that extreme energetic cost.
Right.
It's kind of like she's a high-performance sports car, right?
Yeah.
One that constantly, urgently needs refueling. And let's look at the mechanics of that 500-mile Gulf crossing you mentioned, because it sets the stage for the whole breeding season.
It really does, because avian physiology processes fat entirely differently than mammals do.
Right. They go through this hyperphagy phase prior to migration.
Exactly. They aggressively feed to double their body mass, and they store it all as these specialized lipid reserves.
And the craziest part to me is during that 18 to 22-hour nonstop flight over the Gulf, as she's burning off those lipids, the metabolic oxidation of the fat actually releases water.
Yes, as a byproduct.
Which is the only thing keeping her from dying of acute dehydration over the open ocean. I mean, wow.
It's a perfectly engineered biochemical reaction, but it means she arrives on the Gulf Coast incredibly lean. She has completely exhausted those reserves.
Right, and she immediately has to start doing the localized ecological math of raising young. And she does this with zero assistance from the male. Completely solo mission.
Yeah, the sexual dynamics here are fascinating from an evolutionary game theory perspective.
Game theory? How so?
Well, the males arrive on the breeding grounds roughly a week earlier. They're tracking the northward bloom of tubular native flowers.
Just following the food source.
Exactly. And when a female arrives, the male engages in this highly elaborate pendulum arc display flight. He's basically demonstrating his aerodynamic fitness.
Like, look how fast I can fly.
Right. And they mate, and then he immediately departs. He just vanishes to secure and aggressively defend other nectar territories, looking for other mates.
So no parental investment at all?
None whatsoever, which, people might see as a failure of partnership, but it's actually a mathematically perfect evolutionary strategy.
Okay, I have to play devil's advocate here. Why doesn't he just stick around and help forage?
Well, look at the visual difference between them.
The extreme sexual dimorphism.
Yeah. Right. If we connect this to the bigger picture, the male's iridescent ruby gorget, his throat isn't just a regular color, it's structural coloration.
Right, it relies on microscopic platelet interference in the feathers.
Exactly. It refracts light to flash like a neon beacon, a literal starlight.
Oh, I see where you're going. A neon beacon completely breaks the cardinal rule of nesting.
Camouflage, exactly. A nest is inherently a stationary, vulnerable asset.
Right.
If a male with a throat like a stoplight was hanging around, participating in incubation, he'd instantly act as a target indicator for every predator in the canopy.
Crows, jays, snakes, everyone would see him.
Oh, for sure. Plus, because their energetic margins are so incredibly thin, 2 adult hummingbirds foraging right next to a single nest might actually deplete the local nectar faster than the flowers can replenish it.
That makes total sense.
Yeah.
So his absence is really a deliberate energy-saving feature for her territory.
It's the mathematically stable outcome.
And her plumage, that emerald green back and the white underneath, provides perfect countershading. She blends right into the dappled canopy light.
She is biologically optimized for complete self-sufficiency.
Which brings us to the actual engineering of the nest itself. Because she's entirely on her own, and she's burning energy at this catastrophic rate, she has to build a highly specialized fortress.
The site selection alone is incredible. It reveals this innate understanding of the environment.
Yeah, the sources say they typically pick a downward sloping branch, usually slender oak or birch, maybe 10 to 20 feet up.
And crucially, they build it directly over a stream or a forest path.
Right. The placement over water is just brilliant. It exploits microclimates. The moving water acts as a thermal buffer against sudden temperature drops at night.
Yeah, and that rising column of humidity likely keeps the nest materials supple instead of brittle.
Wow, that's wild. And the nest is tiny, right?
Oh, it's the size of a quarter. She uses plant down, bud scales, and then she meticulously shingles the outside with fragments of gray-green lichen.
Which is textbook disruptive coloration.
Yeah.
It breaks up the visual outline, so a scanning predator just sees a natural knot in the wood. But here's where it gets really interesting.
The biocomposite material.
Exactly. The secret ingredient she uses to bind it all together. Because a rigid mud cup, like an American robin builds, would crack.
It would fail catastrophically. The internal pressure of 2 rapidly growing hummingbird chicks would just shatter it.
Right. So she actively hunts down spider webs and old egg sacs.
Yeah.
To harvest spider silk. It's basically the avian equivalent of maternity sweatpants or an expanding suitcase.
I love that analogy. It's perfect because at a molecular level, spider silk is the defining structural innovation of this whole reproductive cycle.
It's just incredible.
She's weaving a dynamic load-bearing matrix. Spider silk has these crystalline beta sheets for immense tensile strength and amorphous protein chains for high elasticity.
So she's using it like rebar in concrete, but it stretches.
Exactly. As the chicks grow, the nest literally expands to nearly twice its original diameter. She wraps the silk around the branch in these rapid, looping flights.
But once this elastic nursery is engineered, she runs into her greatest physiological paradox.
The nocturnal dilemma.
Right. She lays 2 tiny white eggs, roughly 13 by 8 millimeters, like the size of a jellybean. And we know hummingbirds use torpor to survive the night.
Yeah, to conserve fuel, they downregulate their whole autonomic nervous system.
Heart rate drops to a 50th of its baseline. Body temp drops to near the ambient air. It's basically suspended animation.
Right. But waking up from that requires a massive surge of internal heat. She has to metabolize brown fat just to jumpstart her central nervous system.
But wait, if she's incubating eggs, she can't use torpor, right? Because wouldn't the eggs freeze?
That is the hidden sacrifice of motherhood here. The physics of heat transfer dictate that if she entered torpor, the thermodynamic gradient would reverse.
Her cold body would pull the heat out of the embryos.
Exactly. It would permanently arrest their cellular development. So on cold nights, she simply cannot use her primary survival mechanism.
She basically has to act as a biological space heater.
She stays entirely active, burning her own critically depleted energy reserves just to keep those 2 eggs viable.
Sitting there for 15 to 30 minutes, then sprinting out to eat so she doesn't starve, then sprinting back to warm the eggs. Talk about a razor's edge.
It's an intense 12 to 14 days, and then the hatching happens.
And the chicks are altricial, which means shockingly underdeveloped.
Right. Blind, naked, short, blunt bills. The sources compare them to fat bumblebees.
Fat bumblebees. I mean, they have zero capacity for independent thermoregulation. And they need feeding every 20 to 30 minutes.
And that feeding process.
Oh, wow. Yeah, it looks completely jarring.
It looks alarming.
It looks aggressively violent. She hovers over the cup and plunges her needle-like bill deep down into the chick's throat. It looks like sword swallowing.
It really does.
Yeah.
But biologically, there's nothing wrong. It's a highly precise maneuver.
Right, because their throat muscles can't actively swallow yet.
Exactly. She has to completely bypass the glottis and deliver the food straight into the proventriculus, the first part of their digestive tract.
And what she's feeding them is crucial, because you can't build massive slight muscles and bone density out of pure sugar water.
That's a huge misconception. Nectar gives the mother the immediate cellular energy ATP to keep her own muscles firing. But chicks need complex amino acids. They need nitrogen.
So she's secretly operating as this hyper-agile aerial predator.
Oh, absolutely. She's hawking microscopic insects out of the air, plucking tiny spiders off the undersides of leaves.
And she mixes all that high-protein biomass with nectar in her stomach and regurgitates this specialized, nutrient-dense slurry.
And the growth driven by that slurry is staggering. A chick will undergo mitosis so fast, it roughly doubles its total body mass in the first week.
Which means you can actually see that spider silk nest stretching taut as they fill up the entire inside of it.
It's incredible to witness, and it accelerates them toward a really abrupt departure.
Fledging. Yeah. And it happens fast, right? 18 to 22 days.
Very fast. And unlike, say, a sparrow, there is no gradual learning curve for flight.
Yeah. A normal bird might hop around the bushes for a week figuring out how to glide. A hummingbird can't afford that.
The aerodynamic physics are just too complex, and the energetic cost is too high to learn by trial and error.
Right. Their wing musculature is pre-built. Their wings articulate at the shoulder joint, kind of like helicopter rotor blades.
Generating lift on both the downstroke and the backward upstroke.
Right. Their supracoracoideus muscle, the one for the upstroke, is massively hypertrophied.
Exactly. And the neural pathways for coordinating 50 to 80 wing beats per second are completely established before they ever leave the nest.
So they basically fly on their first try, they grip the edge of the nest, buzz their wings to test the resistance, let go, and they're gone. Pre-programmed.
It's astonishing, and the post-fledging dependency is remarkably short, just 1 to 2 weeks.
Because the margins are so thin, they have to learn to forage fast.
Right. The mother guides them to dense floral patches, but they have to calibrate their own hovering mechanics quickly, because very soon they have to start their own hyperphagia to migrate solo.
So what does this all mean for you, the listener? How can you actually witness this in your own backyard?
Well, the field notes provide some great actionable takeaways. Timing and spatial awareness are key. From mid-May through June, scan the woodland edges.
And don't just look for the bird itself.
Right. Look for a female gathering spider silk or cattail down. And when you see her, track her exit vector.
Follow where she goes. Scan the downward sloping branches for that lichen-covered bump.
Exactly. And most importantly, if you want to support them, plant native tubular flowers.
Things like trumpet vine, cardinal flower, bee balm.
Because those plants co-evolved specifically with the hummingbird's morphology. You provide the sucrose, they act as targeted pollinators.
But there's a really strict rule if you do find a nest. Perimeter discipline.
Yes, this is critical. You must stay at least 20 feet away using binoculars.
Because if you breach that perimeter, she sees you as a terrestrial predator. Her stress hormones spike.
And she will do the math. She'll realize the localized risk outweighs her biological investment, and she will abandon the nest entirely.
20 feet. It's a small boundary to respect what is essentially a monastic effort.
Monastic is the perfect word for it.
I mean, think about it. 1 brood, 2 eggs. She builds an expanding spider silk fortress. She gives up her own torpor survival mechanism to keep them warm.
Processes thousands of tiny spiders into fuel.
Right, and gives absolutely everything she has for 6 weeks, all before turning back to face that 500-mile open water over the Gulf again.
It's awe-inspiring. But before we wrap up, I want to leave everyone with a final, really provocative concept to mull over.
Oh, I know where you're going with this, the navigation.
Yes. We know the mother leaves the chicks, and those chicks, only a few months old, eventually migrate entirely alone across the Gulf of Mexico.
With no adults showing them the way.
Right, so imagine the profound power of that genetic memory. How does a creature the size of a bumblebee that's only ever seen one patch of forest navigate 1,000 miles to a specific spot in Central America?
It's quantum mechanics, isn't it?
It is. It involves these specialized light-sensitive proteins in their eyes called cryptochromes.
Which is just mind-blowing.
When light hits these proteins, it creates a radical pair-2 molecules with entangled electrons. And the spin states of those electrons are so sensitive, they are altered by the Earth's magnetic field.
Wait, really? So they don't just have an internal compass?
No, the implication is that through quantum entanglement, they might literally see the magnetic field superimposed over their vision.
That completely reorganizes how you look at them. They have this innate celestial and magnetic map hardwired into their brain.
Guiding them thousands of miles, carrying the legacy of that tiny spider silk nest inside their DNA.
Unbelievable. A nickel-sized bird using quantum mechanics to fly across the ocean. Thank you so much for joining us on this deep dive, everyone.
It's been a great conversation.
Keep your eyes on the trees, respect that 20-foot perimeter, and as always, stay relentlessly curious.